This conference will now be recorded.
So now here, if you observe, so morning we discussed about these constructors. So basically, we're having two types of constructors. So what is a constructor? So how to define a constructor? So whether they, how to identify a constructor and program on some couple of programs and constructors as well. And we discussed some types of constructors as well, right? So I think lastly we discussed about, uh, is it possible to override the constructors or not? As it is possible to overload the constructors in Java, but it is not possible to override the constructors in Java because constructors are not inheritable from superclass to subclass. So nothing but basically we discussed completely. We have discussed the concepts which is related to constructors, and we have discussed some types of constructors as well. And when the default constructor is going to provide it, it is going to provide by compiler, not by JVM. These things we have discussed, right? So now we want to discuss about this instance context or instance flow of execution. So maximum we try to complete this till this keyword. Okay, today even our internet need to support. We will check it. Okay. So last we discussed one interview question. So is it possible to overload the constructor or not? Yes, it is possible to overload the constructors in Java, but it is not possible to override the constructors in Java because constructors are not inheritable from superclass to subclass, right? So now we need to discuss about this instance context or instance of execution. Okay, so in Java, instance context is represented in the form of the following elements. One is instance variables. Second one is instance methods. Third one is instance blocks. Okay, so instance variables, instance methods, you are having some idea basically, but you don't know about this instance block, how to define this instance block as well, right? So we'll discuss these things now. In Java, for every object a separate instance context will be created. Sorry, in Java for every object a separate instance context will be created. So first one is instance variables. Okay, so now here whatever the concepts we're discussing, instance context and even static context, which we want to discuss. So it is somewhat not a difficult exactly. So if you're strong in the previous concepts, I mean, whatever the constructors are boosting hash code which we discussed. So if you're strong in these concepts are very easy to. Okay. Still, if you are not able to get somewhere, please let me know. Instance variables is a normal Java variable whose values will be varied from one instance to another instance. Yeah. Instance variables are not available, whose values will be varied from one instance to another instance of an object. Instance variable is a variable which will be recognized and initialized just before executing the respective class constructor. Respective class constructor. Instance variable is a variable which will be recognized and initialized just before executing the respective class constructor. So constructor we have discussed here. I mean how to create a constructor, when the constructor is going to execute these all these things. So whenever the constructor is executing, just before executing the constructor, so this instance variable is going to be recognized and initialized. Here initialized means, so if you remember, so we discussed about, so how this JVM is checking, so where exactly this instance variable declaration is done or not. So we discussed about two concepts there. One is it will check at constructor level and as well as a class level declaration. So if if this declaration is not happened in any one of the way, either at constructor level or declaration, then JVM is going to the default values, right? There is nothing but what is exactly initialized. Okay. So in Java applications, instance variables must be declared at class level and Java applications instance variables must be declared at class level and non-static instance variables never be declared as local variables and static variables. In Java applications, instance variables data will be stored in object memory, that is heap memory. That is heap memory. Okay, these are the points which comes under instance variables. Instance methods here. Instance method is a normal Java method. It is a set of instructions it will represent an action of an entity. So in Java applications, sorry, instance methods will be executed when we access the method. In Java applications, all the methods will be executed without the proper method call. Okay, so here 2 points. So one is if you observe instance method. So what are the uses which were discussed? Just is a normal method call. So we know that how to create an instance method, and even we know that how to call that instance method, how to catch the respective different type. So these all these things we have discussed, right?
This conference will now be recorded.
So these are the 2 points which we discussed already. Okay. So generally, if you want to define some instance methods, how it will be available. So let us assume some we're having class echo, we're having some public void add string account number, maybe string account name, string account type, right? So this is one instance method. So and even we can write it like this: public void search string account number. So this nothing but these two are instance methods only. Okay. Now we can see some example programs. I mean, this programs and instance variables are executed before executing the constructors or not. I mean, what are the instance variables and instance methods which we have discussed. So some flow of execution programs now we are going to discuss. Okay. So these programs are very important.
This conference will now be recorded.
So now if you observe here, we're discussing about this instance context or instance flow of execution, right? So now any of you can guess the what is the output for this program? Any of you? Any of you? What is the output of this program? First of all, can we get some output or not? Or output maybe some what we can say that maybe some blank. A con blank. Okay, there is a output. Okay, let me explain.
This
Statement.
conference will now be recorded.
Here I have mentioned one statement if you observe. Okay, so instance variable is a variable which will be recognized and initialized just before executing the respective class constructor. This is the point which I mentioned. right? So this is a theory point. So now I want to prove it is I want to prove in practical point of view. So now if you observe, this is a constructor which you know already, right? And this is a int I. This is nothing but a instance variable. What is the value of I? Any of you can guess what is the value of I? So value of I is nothing but a 10. So if you observe, so we are calling M1. So whenever calling M1, so now first it is going to call M1 method and it is going to print M1A. And here after that statement, we are returning some value as a 10. That is the value of I. Okay. Now first it will print output as a M1A. So this is the practical proof that so instance variables, right? Instance variables is going to be initialized before executing of a constructor. After M1A, it is going to print acon. Okay, so let us execute this program. See here, what is the output? Nothing but M1A and acon. Okay, this is the practical proof. Instance variables is going to be initialized or loaded just before executing the constructor. This is the practical proof. So I hope everybody got this concept, whatever the flow which I've explained you.
This conference will now be recorded.
Abdul, you can ask the question.
Uh, yeah, sure. In that program, we are just initializing the instance variable, right? But we are not calling that instance variable I. Then how come it is printing the output of the method M1?
I did not get you.
Uh, in line number three, we are just initializing the
Mm-hmm.
variable I, right?
Hmm.
And we are not calling that variable I in the main program. I'm
Not
just wondering.
basically here. Generally, if you want to call this method, how we are calling nothing but a.m1, right?
Yeah, correct.
This is the way we call it, right? Yes.
Yeah,
Okay.
yeah,
So now here, if you observe, if you want to initialize some variables, how we are initializing int I is equal to 10, right?
yeah.
Yes. So here, my point is, so this is the theory point. What I'm telling. Okay, just instance variable is going to be initialized just before executing that class constructor, right?
Yeah.
So for that reason, so what I have done is instead of initializing or instead of calling this method like this, so I have provided int I equal to m1. So nothing but now this variable, this is a variable of this is nothing but instance variable, right? Instance variable is going to be initialized just before executing this constructor. This is a constructor, right? So just before this constructor, it has to be initialized. So that is then just I am calling like this m1. So once if I am mentioned like this, now it is going to call this method. So now m1 is going to print and the variable, I mean after return statement, whatever the value we're having, that value is going to be initialized. It is going to be assigned to I. Just for practical purpose, I am defining like this. Okay, this is not a real time. Just in order to
Oh,
prove this one. Okay,
oh,
so you
okay.
got
But
it.
still, the- uh, yeah, sure. Can you hear me?
Yes, tell me.
Yeah, but still we are initializing, right, before constructor.
Yes.
So even though we initialize, the program will still be able to call that method to print.
We are initializing, right? That is the reason it is calling.
Yeah,
If you
initializing
observe what
and
is the
calling are
output.
different, right? Yeah,
Initializing?
initializing and calling are different, right?
No, here at a time it is going to call and initialize. That is the thing. Here
Oh,
it is
call and
only
initialize.
calling we are.
Okay, it is
Yes.
going to call and initialize. It is going to do both. Okay.
Yes. Yes. Yes.
Uh,
But
okay,
in
thank
real
you.
time, we are not doing like this. You don't have to worry
Uh,
about in real time.
okay.
Just for satisfaction of the student. Okay, this is nothing but a theory part. How we can do it as a practical means this is the way. Just for satisfaction of student or satisfaction of concept, both theory and practically. So I have created this type of problems. Okay.
Okay, thank you.
But in real time, we are nowhere calling like this in type equal to m1. So like this only we are defining, and like this only we are calling. Clear, all of you? So class A. So here I am creating a one more class. Just same program. Just I'm changing some piece of code. Okay. So just I need to get output from you. So int j equal to m1, int m2, system dot system dot out dot internal econ int m1 system dot out dot internal m1a. Sorry, need to go return statement as well, right? Return 20 int I equal to m2 was test public static void main string args in some small is equal to immediate system dot internal a dot I a dot j a dot m1 a dot m2. Let me save it. So anybody guess this output? What is the output for this program? So same thing, whatever the program we're having, same program, only just one difference. Just I have added a one more method. That is the only difference. Okay. So let me give some spaces if you're getting some confusion. So what is the output? What is the output? Can we get some output or not, first of all? Or can we get any compile time error? Because let me check it from my end. It is closed. It is closed. It is closed. It is closed. I hope there will not be any compile time error. Think and tell me, okay? Because this instance contest or static contest, so right, and even this keyword, so it will take minimum 1 to 1.5 hours, or even some 2 hours also to complete the concept and practical. There is somewhat confusion concept as well. That is the reason I'm asking. Okay, let me explain you all this. Okay, nothing simple. So first of all, don't worry about this constructor. So it will always going to execute lost. That answer is wrong. Okay, so it will always execute at the lost. Okay, first comes here int j equal to m1, right? So int j equal to m1. So now here, what is various that we having? This is the thing. So nothing but in this one m1a, and after that return 20. What is the j value here? Nothing but it 20. Okay. Okay, so this will not execute. It will not. It will execute at the last only. And after that, here int I equal to m2. So now it is going to print output as a m2a. So m2a, and now it will execute icon. So this thing is done. Okay. Now here what we're doing, system.out.println a.i. What is a.i? I mean, what is the I value here? So it is calling m2. M2 return 10. I mean 10 is the value. And a.j nothing but 20, and a.m1 and a.m2 we're calling, means m1a and okay. So try to execute this program. So java c test.java, java test. Here what is output? m1a, m2a, icon 1020, m1a and m2a. Okay, so this is the output for this program. Abdul, is it fine for you? All of you? Yes, programming execution is fine. Or if you are not getting something, let me know. I'm going to explain. So where you did not get it, let me know.
Uh,
Yes.
yeah, sure. Flow of execution. Whatever the case, it is just going to initialize first and just going to call.
Yes.
Okay.
So here, uh, constructor is going to execute lost only. Okay. As per
Yeah,
what we
yeah.
have discussed. So just first it is going to initialize, then only constructor is going to execute, right? So you don't need to worry about these constructors. So first is going to execute either M2 or M1 method based upon this order. So here, if you comes under class A, so we're having into J equal to M1. So now it is going to execute M1 method, right? And int I equal to M2, now it is going to execute M2 method. And last it is going to execute constructor. Okay.
Okay.
Instance block. Instance block is a set of instructions which will be recognized and executed just before executing the respective class constructors. Okay, instance block is a set of instructions which will be recognized and executed just before executing the respective class constructor. I mean, it is same way as instance variables. Okay, so whether if you go for instance variables and instance blocks, so when there is a chance of executing is just before execute the constructor, this even this instance block also going to be executed. Okay, instance blocks are having the same power of constructors. It can be used to improve the code related to resource creation like streams, files, database connections, these things. Okay, so that is a purpose of instance block. When we can use the instance block is, for suppose just I want to connect a database. Okay, just before saving an object state to a database, before that just I want to connect to a database, so then we can go with the instance block. Okay, so now if you go with some piece of code or before that, so if you go with the syntax, so here instructions we can do it. So like this is a piece of code, so like this we need to define a instance block. Okay, so let's go with some example. See here. So we're having a class A, and within the class A anyway constructor is there, and this is the instance block. Okay, this is the instance block, and after that I have created one class name. There is nothing but a, maybe we can say that just 7, right? And I have created an object. So let us save this program. So nothing here, output is simple. So anyway constructor will not execute. First is going to execute on instance block, right? So nothing but first is going to print output as IBA and A1. So Java C test 7 dot Java test 7. Here IBA and A1. So is it fine, all of you? So now here, if you observe this program, what I have done is I have included instance variable, instance methods, and even instance block followed by constructors. So if you observe previous programs, we discussed individually instance variables and instance blocks, constructors were discussed individually. Now all these three concepts I have included in this program. Okay, so if you observe, this is nothing but an instance method, right? This is nothing but a instance block. Okay, here it is the instance variable. This is a constructor. Again, this is an instance block, right? So just create only one object. So what is the output for this program? Anybody? It is tricky as well. What is the output? Can we get some more? Sorry. Can we get some output first of all? Okay, fine. Observe here. So here we will not execute. What is the first output we're going to get? IBA, right? And then int I1 is equal to M2. Where is M2 method? This is the M2 method. After IBA, it is going to print output as an M2A, right? So now there is no chance of execution. It is a constructor int I equal to M1 and M1A. First IBA, M2A, and M1A. Again, we are having instance block IB1A. Okay, there is a thing output till now, and here now we are calling, and lastly A1. This is the output. Okay, so try to execute this program. See here, this is the output. And here, if you observe, in Java, for every object, a separate instance context will be created. This is a theory point, right? So we can prove it practically now. So now here, I am creating a one more object. Whenever I am creating a one more object, right? Again, new instance context will be created. See here? So this is the practical proof for each and every instance, or whenever if you are creating an object for a particular class, for each and every object, instance context is going to be shared. Okay. So this is the point. In Java, for every object, a separate instance context, not exactly sharing here, sharing is wrong. Okay. For every object, a instance context will be created. Okay. So this is one object. So we have got one output. and we are creating a one more object, right? Again, new instance context will be created. Okay, so this is the practical proof for this respect to point. So is it fine? Are we getting or not? I don't know.
This conference will now be recorded.
This keyword. This is a Java keyword. It can be used to represent current class object. Okay, this is Java keyword. It can be used to represent current class object. Okay, in Java applications, we are able to utilize this keyword in the following ways. To refer current class variable, to refer current class methods, to refer current class constructors, to refer current class objects. Okay, to refer current class variable, current class methods, current class constructors, and current class objects. Okay, so first one, to refer current class variables. So if we want to refer current class variables by using this keyword, then we have to use the following syntax. That's it. That is this dot variable. Okay, so note, in Java applications, if we have the same set of variables at local and at class level, and if we access that variables, then JVM will give first priority for local variables. If local variables are not available, then JVM will search for that variables at class level. Even at class level also, that variables are not available, then JVM will search at superclass level at all the above locations. They specified variables are not available, then compiler will raise an error. Okay, so in Java applications, if you have the same set of variables at local and class level, means, but suppose if I am defining some class here, int I equal to 10. This is the instance variable which you know, right? Void num1 int I. So now if you observe this variable, right? This variable is the same as, whatever the variable name which I have defined for passing of parameters for m1, this variable name is also same. Whatever the variable name here I defined I, and here also I. This I is the local variable, and this I is nothing but an instance variable, right? So now if we have the same set of variables at local and class level, and if we access that variables, then JVM will give first priority for local variables. If local variables are available, then JVM will search for that local variables at class level. This is the class level. Even at class level also that variables are not available, then JVM will search at superclass level. At all the above locations, if the specified variables are not available, right, then compiler will raise an error. That is the meaning here. Okay. And here we're having a one more note point. In Java applications, if we have same set of variables at local and at class level, then to access class level variables to our local variables, we have to use this keyword. So if you observe in the previous program, just I have within the paint I have mentioned some program, right? So if you observe there, instance variable and as well as a whatever the method, for a given method we are passing some parameter, right? That variable name and instance variable name, both variable names are different. So nothing but, sorry, both variable names are same. So now if you want to differentiate, so which variable is instance and which variable is a local variable, right? So then we can use, by using this keyword, so easily we can differentiate. So this variable is an instance and this variable is a local variable. Okay. Clear these 2 points, all of you? So let us have some program. simple program to refer and class variables. Class A int I equal to 10, int j equal to 20, int I, int j, I plus this dot I cos test 0, public static void main string args, of a moment, right? Okay, let's save this program. So now if you observe here, right? So this is a constructor which you know, and this is a parameterized constructor. So and if you observe for this constructor, I am passing some variables. So here, what are the variable names which I have defined for this constructor, right? Yeah, it is the same variable names for instance variables. I mean, here these are the instance variables and these are the local variables. So here, so now if you want to, whenever if you're defining that, whenever if you're defining some instance variables and local variables, which is having the same names, so JVM is going to get some ambiguity problem. Ambiguity means a confusion. It was unable to recognize which are instance and which are static. Okay, so now if you want to give some preference, or if you want to tell to JVM, these are the instance variables, right? You can use this keyword. So whenever if you're mentioning like this dot I means now it is going to print only instance variable values, this dot I and this dot j. So now here we are passing 100 and 200. These are the values of I value is 100 here and j value is 200, and it will print the output as a 100 and 200. So whenever I'm mentioning this dot I and this dot j, so it will print the instance variable values. Okay. So let us execute this program. Now see test 0. Error is error. It is closed. It is also closed. It's closed. It is also closed. Okay, equals. Again error. Java 2. Just give me a little bit equal.
This conference will now be recorded.
I think this thing is not taking. Yes. Java test 0. See here 100 and 200 and 10 and 20. So is the concept is fine first of all. So when we need to go for this keyword, when we can utilize this keyword for instance variables and local variables? To refer current class variables. Here current class variables means instance variables only comes under current class variables, not a local variables. Okay. So here I am referring the current class variables. That is the reason here I am going to take this keyboard. Clear? I hope this point is clear, all of you. So still, if you have any doubts, let me know. Second, to refer current class methods. So if you want to refer current class method by using this keyword, then we have to use the following following syntax. This dot method like this. Okay, this dot method name always on parameter listing. Okay, so if you observe previously, so whenever if you are defining some instance and local variables are same names, so then if you want to differentiate these variables, we have used this keyword, right? So same way now, even we can use this keyword for methods as well, right? So open here the methods, we will discuss a sample program. I think somewhere my programs are missed, but let me write it right now. These programs. What's on these programs? Loaded M1. System.out.println. Because generally why I will not write programming again is going to take time, right? These are lengthy sessions. Void M2 system.out.println. This one is closed. This one is closed. This test 01. Let's save this program. So now if you observe this program, nothing very simple. Just I have created two instance methods, right? But within this M2 method, I am calling M1 method like this dot M1 method. So whenever if you're calling this dot M1, right, this is always point to current object. So if you observe here, we have created an object for class A. Now within this class A, do we have M1 method or not? Yes, we have M1 method. Now it is going to execute this method, this dot M1, and the same way for normal M1 method call. So this is a normal method M1 call, and here also we are calling the M1 method by using this keyboard. Nothing difference. Only whenever if you call this dot M1, it is always going to call within class A M1 method. Okay, so nothing but current class method only is going to call. That's it. So let's try to execute this method. Java C test. Java test.
This conference will now be recorded.
Refer current class methods. And next one, to refer current class constructors. So if you want to refer current class constructor by using this keyword, then we have to use the following sentence. So like this. Okay, so if you want to call the current class constructor, so like this you can call. Okay, so let's go with some program. I think we have this program.
This conference will now be recorded.
Okay, now it's recording. So now here to refer current class constructor here first of all. So now if you observe, so how many constructors we are having within this program? Anybody? How many constructors we are having within this program? Four. Yes. So here we are having a four constructors. So here we are having a four constructors here. So this is one, and this is one more, and this is one more, and this is one more. So here generally most of you are going to expect output as A0 or con, A float int con, A float param con, and A double param con. So like this you're going to expect some output, but the output is not. Output is reverse. Why it is reverse now? So now here whenever I'm calling A sum small is equal to new A. Now within this class it is going to check, do we have any default constructor or not? Not exactly default. Now it is going to check, do we have any constructor with zero argument parameter or not? Yes, we're having an argument with zero argument parameter. Now within this constructor, so we are mentioning as a this of 10. So now there is no chance of executing this statement. Now immediately, now within this clause here, now it is going to check. So do we have any constructor with parameter as int data type? Yes, we have a constructor with parameter as int data type. Now it is going to execute this constructor, but within this constructor, we are calling this of 22.22f, right? Nothing but a. Now within this clause here, it is going to check, do we have any constructor with float as a parameter? Yes, we have a constructor with float as a parameter. Now it is going to call this constructor. Now within this constructor, this of 10.0, nothing but it is a double. So now within this clause here, it is going to check, do we have constructor with double as a parameter or not? Yes, we are having constructor with double parameter. Now it is going to execute this constructor, and finally it is going to print output as a double param con. So this constructor where it is called here from here, right? So now it is going to print this one, a float param con. This constructor where it is called from here. Now it is going to print output as a float int con. this constructor, it is called here. Now it is going to print output as A0 argument. Output is a reverse. So let us try to export. So Java C test 14 dot Java test 14. See here, this is the output. So is the programming flow is fine, everybody? I mean, whatever the programming flow which I told you, program flow of execution or flow of execution is fine. How do you get it? Or if anybody did not get it, let me know. Fine. Okay, you need to practice n number of times, then only you are going to get it. To refer current class object. To refer current class object, that is the fourth one. So by using this keyword, it is referring to current class object as well. So this thing you need to get only practically. Theory wise you are not able to get. So how it is referring? So you can get it practically. Okay. So now let me explain this program as well. Okay. This is somewhat tricky. So listen carefully. So now if you observe, so within this class, do we have constructor or not? First of all of you. Within this class A, do we have constructor or not? Yes or no? Do you have constructor? First of all, okay, maybe. So here we don't have constructor first of all. Okay. So what about this one? So if you observe basic programming skills, so basic syntax, what we do is a basic syntax, return type followed by some method, right? So now here return type it can be a class, it can be interface, it can be a data type, data types, it can be a what. So like this we have defined, right? So now here if you observe here return type is a class. This is a method name. Okay, here A is nothing but return type is a class A. Okay, so is it clear, all of you? Get reference one and get reference two, these are the methods, and these are the return types. Here return type I have taken as a class. Okay, is it clear? Any doubt? Okay, so now here observe carefully. I have created an object for this class. Okay, so you know that whenever I'm printing like this, so you know that it is going to call toString method, right? It is going to call toString method. Okay, so now here a dot get reference one, a dot get reference one, a dot get reference one. Okay, so the thing, but I'm calling how many times here? Three times. Same way, a dot get reference to, a dot get reference to, a dot get reference to. I mean, three times I'm calling get reference one method and get reference to method as well, right? And here we are going to get, I mean, we're going to get reference value. Okay, we're going to get a reference value for that respective object. This thing you know already. So here whenever I'm calling a dot get reference one, within this get reference one, what is going on? So it is creating a new object. It is returning that respective object. So how many times you're calling? Till that many times it is going to create. I mean, each and every time, whenever if you're calling, for each time it is going to create a new object, and it is going to return that respect to reference variable or a reference value, right? But if you observe here get reference to method, so return this. So this means this is always pointed to current class object. So here what is the current class reference value we are printing? So maybe let us assume we have got some ABC123 as a reference value. That is the same value for this three methods. I mean, for this statements, for the statement which I have highlighted. Okay, for these three statements. So whatever the reference value which we are getting from 18 statement, that is the same value for this 24, 25, 26 statement. Reason is return this. Here we are not creating any object here. Return this. This is always pointed to current class object. Okay, is it fine? Let me know, all of you.
This conference will now be recorded.
So let us save this program. So then if you are not getting something, please let me know. I can explain n number of times. There is no problem. I need to get the concept. That's it. So if you observe these three values, right? That is get reference one. Three times we are calling. For each and every time a new object is created and a new reference value will be written. That is the reason here reference value is differentiated. But here if you observe 18 statement output is ending with 9742. These are also 9742 because here we're calling get reference to method and it is returning this. This is always pointing to current class object. So my intention is this is always pointing to current class object. So by using this example, right? So this is always pointing to current class object means here it is always pointing to reference value of the current object by using this method, get reference to method. So by using this example, I am telling you practically this is always pointing to current class object. Okay. So is the program and output is good is fine or programming flow is fine, all of you? Any doubts? Let me know.